In the previous video, Magic, you said that data science is using machine learning to solve very specific business problems. What kind of problems are we talking about?
Right, so that's a bit of a challenging part because there are many diverse applications, as it seems, of machine learning, but they share a common denominator. And this common denominator is not always clearly visible. And also, if you go online and try to look, what kind of problems machine learning is solving, many of those examples I find hard to believe that were actually followed by practical execution. They look quite speculative, as if someone just came up with an idea, oh, this is a good problem for machine learning, while I have doubts.
You're not suggesting that people are online posturing Magic and they're making stuff?
Not at all. Not at all. What I can do is I can walk you through what we delivered historically.
Yeah, that would be great. Some examples that you've actually personally experienced and done. So let's hear them.
They fall into a couple of categories, and maybe we can just break it down like that, because a lot of what we did was for sales and marketing.
Okay.
And then an entirely different category is risk analytics. And then you have applications in healthcare. You have also applications in game development and software development more generally. And most recently, we started doing projects in manufacturing and Internet of Things. It's quite a broad range.
Yeah, and varied in a lot of ways. And let's look at these in a bit greater detail. So let's talk about what you've done in sales and marketing.
Anything that has to do with prioritizing and optimizing your direct campaigns, your targeted campaigns. So when you have free users and you want to bring them into becoming paying users, when you want to cross-sell additional products or upsell to a better product, these are classical applications for data science. On the other side of customer lifecycle, you would have churn models. So they point you towards those customers who are thinking about leaving to the competition. And also they help you to understand what leads your customers to churn. Mm-hmm. A different set of models called lifetime value models. They forecast the revenue you are going to get from each individual customer. And it's good to know.
Right.
And a separate group of models build customer segment. And they are used, if you are able to detect distinct segments of customers, then you can tailor your offer to meet their needs better rather than have one size fit all.
Let's move on to risk analytics.
So one of the major applications in risk analytics is fraud detection models. And you can build them to highlight fraudulent transactions or fraudulent claims in insurance. And similarly, in insurance, you can also build models that assess the future severity of the claim, how much you're likely to pay out, which could be used in provisioning. But the biggest consumers of machine learning are actually banks.
Huh.
And it's quite layered, and it's not like they are using most sophisticated machine learning. They are actually using quite simple machine learning technologies, but the breadth of the adoption is like in no other industry really. So you would have at least three major categories of models used by banks, and one of them probably so these are the models that assess the risk of you not paying back the loan, right?
Right.
So not only they assess you when you apply for a loan, but you may not know that you are being monitored every month.
In addition to my original
Yes.
risk assessment,
Yes.
they're ongoing.
So that's the so-called probability to default models. Then you have another category of models that predict, well, if you stop paying back the loan, what's the exposure here? What's the amount of money at stake? And then the third category of models that actually predict, well, if you stop paying back the loan, how much we'll be able to recover.
Let's now move on to healthcare.
Right. So we built a couple of models here last year, and one of them was to predict the length of surgery. So that's on the patient level, whether a surgery will take 2 hours or 5 hours, and it greatly helps in optimize resource utilization.
Okay.
Another similar model that predicts probability of the patient staying overnight, which is a big deal. And once that, then how long is it going to take? How many days a patient will stay? Models a bit similar to churn, where we predict the risk of patient not showing up on scheduled appointment. But also conversely, once we discharge the patient, the risk of readmittance in a short term.
Okay, so that was the third out of the 5. Let's move on to number 4, games and software.
Right, this is all about user's experience and product quality. So monitoring and understanding the stumbling points, on user journey, starting with the onboarding process and then features of the game or features of the software, what's good, what's bad, what's working, what's not working, how we can improve that, how we can reduce players' churn. But again, a lot of that is not really about machine learning, it's about using machine learning to understand and modify the product that we manage.
Okay, so let's move on to the 5th one you mentioned, and that is manufacturing.
2 big things there. One, it's predictive maintenance models. So we are doing it right now, building models that predict failure of equipment. It's either a machine or it's a whole factory line. And once you have that deployed, then engineers are getting alerts if something is about to go wrong. And the second thing is the whole supply chain optimization. So you can optimize the inventory levels. You can predict and understand anomalies in the process. And generally, you can greatly reduce waste.
I'm curious, how established is machine learning in all these 5 areas?
Oh, it's quite varied, right? So I would say that the sales and marketing and the risk analytics definitely have been utilizing machine learning for decades now. And again, it varies, between organizations.
Sure.
The other implementations are emerging right now, so they are quite new to the table.
Oh, I see.
This is what I mentioned on the beginning. These applications share a common denominator. And machine learning doesn't really care about, whether it's a healthcare or it's gaming, whether it's customers or sensors. The common denominator is that to solve those problems, you can represent them as historical examples of what happened. And as long as data scientists can translate this business problem into this table with historical examples, then machine learning can take it from there and learn from those examples.
Okay, well, this sounds like maybe this is a bit of a simple example, but it sounds like machine learning is almost like a hammer. And the hammer doesn't care if it's being used to build a wall, put up a picture, or fix a fence.
Yes. And if you want to go along with this analogy, you need to be careful, because if you don't know what you are doing, you're going to make a hole in the wall.
Or really whack your thumb, as I've done many occasions. Okay, so let's just do a contrast here to help the audience understand. What would be an example of a non-machine learning problem?
Right. So it's not the only example, but whenever you need an exact answer, and there is an exact answer to what you're asking for instance, if you say want to distribute your budget across sales teams, and for that you need to know how the sales were performing by geography, and you have a gap in your knowledge and you need this insight to make a decision. So to answer that question, you need a report with exact numbers and some charts. That's not a machine learning problem. There are no historical examples to learn from. It's exact numbers that you need.
Which is what you need for machine learning, is those historical examples.
Yes.
Okay. Well, I think this would be a good place to bring the video to an end. I think our next video then would be, what is it that exactly machine learning needs to be successful?
Okay.
Thanks, Patrick. Until our next video.